can see everything and can hear, and I'm not blocking the view too bad in here.
Yeah, I can hear it and I can see it.
Okay, great. All right, so now we have a 100 ohm resistor connected in parallel with a 1.25 microfarad capacitor, and this parallel combination is connected in series with a 30 ohm resistor and an 8 millihenry inductor. Calculate the impedance of this interconnection if the frequency is 8 kiloradians per second. Okay, so we have, we're given a 100 ohm resistor in parallel with a 1.25 microfarad capacitor. And then this is connected in series with a 30 ohm resistor and an 8 millihenry inductor. And we need to calculate the impedance of this interconnection if the frequency is 8 kiloradians per second. Now this is showing the kind of, I want to say sloppiness, but just like shortcut that a lot of people use. This is not the frequency really, this is the angular frequency. And the way I know that is because the units are in radians per second. So I know this is already omega. If it's given in hertz, you need to multiply by 2 pi. So you have to pay attention to that. I suspect that on your test, he'll be real clear and either say frequency or angular frequency or omega, and not like try to mess you up by saying the frequency and then give it to you in radians. But this is telling us that it's actually the angular frequency, and it's 8 kiloradians per second, so the angular frequency is really 8,000. Okay, so now I need to convert these, and so I know a capacitor is minus J over omega C, and an inductor is J omega L. So then this becomes 100, the resistor doesn't change, 1.25 microfarads, is 1.25 times 10 to the negative 6. So I want minus J over 8 times 10 to the third times 1.25 times 10 to the negative 6.
I have a question.
Yeah.
Why are we using the formula for angular acceleration for power omega? Because I thought omega was 2 times pi times f, just the frequency.
Okay, so that's what I was saying just a minute ago, that a lot of times electrical engineers or engineers in general are sloppy. And so when you look at the frequency, if it's given in radians, you know it's angular, because regular frequency would just be hertz. So frequency and angular frequency, a lot of times you don't bother saying the word angular. That's not actually correct, but this was copied from an electrical engineering textbook. And so that's why. So like I was saying, I don't think he would do that to you, but be aware that is how people talk. So you have to listen. If it's given in hertz, then it's frequency, you have to multiply by 2 pi. If it's given in radians per second, then you know it's angular.
Can I grab another one of those?
Yeah. Did you give yours away?
No.
Oh, somebody needs one. Okay. So where was I? I was minus J over 8,000 times 1.25 e negative 6 is minus J100. The 30 ohms stays the same. And then 8 millihenries for the inductor, that will be J times 8,000 times 0.008. 8,000 times 0.008. Those would cancel. The milli, that's probably 64, right? So J64, yeah, it is, J64. Okay, so now that I have everything in phasors, I can just use the rules that we learned for resistors, because they all act like resistors. So in parallel, that's going to be product over sum. So that'll be 100 times minus J100 over 100 minus J100. And then in series, I will just add these, plus 30 plus J64. And plus 30 plus J64 and negative 20 plus J14. I forgot a minus sign in the denominator. $80 plus J14. All right, so then it says, what is the resistive part and what is the reactive part of this impedance? So the resistive part is 80, and the reactive part is 14. And is this a capacitive or inductive circuit? Inductive, because this is positive. Okay, now it says repeat for a frequency of 4 kiloradians per second. I'm actually not going to do that because it's exactly the same idea, but I will tell you what the answer is so you can check on your own. The answer for that, if you want to just practice yourself, would be 110 minus J8. Oh, and I would have gotten a point off and I would have felt so stupid because I left off my units. These are ohms. Okay, at what finite frequency does the impedance of the interconnection become purely resistive? Okay, so that we have to look at and figure out where it would become purely resistive. And so now, let's say we've got our this and a capacitor and a resistor and an inductor. Now, I would love to be able to say, oh, I know this. My angular frequency for resonance is 1 over the square root of LC, but I can't use that here because this is neither series nor parallel. This is good if you have a series or parallel. If you have either so you have resistor, inductor, capacitor, or if you have resistor, inductor, a capacitor, then the resonant frequency is 1 over the square root of LC. But this is neither of those, so I can't do that. And so I need to look at what the imaginary part would be. This was 100. This is minus J over omega C. This was 30. This is J omega L. So my entire impedance, if I don't know the frequency, is 100 times minus J over omega C over 100 plus minus J omega C plus 30 plus J omega L. And then if I multiply top and bottom here by omega C, I get minus J100 over 100 omega C minus J plus 30 plus J omega L. And now if I multiply this by the conjugate, minus J100 over 100 omega C minus J times 100 omega C plus J over 100 omega C plus J plus 30 plus J omega L, I get minus J10000 omega C plus 100 over 10000 omega squared C squared plus 1 plus 30 plus J omega L. Now I want to find out where I have my impedance is purely resistive. So I need my imaginary part to be 0. So I need minus J 10,000 omega C over 10,000 omega squared C squared plus 1 plus J omega L to equal 0. And then at this point, I would plug in my values for C and L and solve for omega. You can divide by J, so that goes out. So we have minus 10,000 omega, and C was 1.25 times 10 to the negative 6 over 10,000 omega squared 1.25 times 10 to the negative 6 squared plus 1 equals negative omega times L, which was 0.008. And then I would end up with I believe if you solve for this, you get 36 times 10 to the 6. You shouldn't have to do this on the test, I don't think. I think if you were given one, it would probably be series or parallel. I can't say that for sure, but it'd be an awful lot of arithmetic to do to come up with this answer. But I think that'd be omega squared is 36 times 10 to the negative 6, and that would get omega equals 6,000 radians per second. I'm not entirely sure. I'm pretty sure that's right. 100 squared omega c, 100 squared omega c plus 1 plus 30. Looks like I forgot my, oh no, I got rid of that. Yeah, pretty sure that's right. Okay. But I doubt you would have to do that, but you do need to know the concept. You definitely do need to know that the resonant frequency is 1 over the square root of formula sheet. You asked what you should have on the formula sheet. Resonant frequency for series or parallel. So omega naught for series or parallel is 1 over the square root of LC. So this is the resonant frequency for parallel or series inductor, resistor, capacitor, and this is when the impedance is purely real. So purely real, and another way of saying that is purely resistive.
So you're saying if we just plug in the L and the C and the answer, what we get is the answer for that question, basically, if it was parallel or only series?
Yeah.
Okay.
Yeah. And I have several videos where I've worked that out. I've done that several times. Not this year, I've only done it once this year, but I've done it several times in the past. Okay, and then what is the impedance at the frequency found in C? Okay, so the impedance for the frequency found in C, it would be nice if we could just say that, like if I had series, then my impedance at the resonant frequency would just be the resistor. If I had in parallel, the impedance again would just be the resistor. That's not going to be true in our case because it's not either series or parallel. So you would actually have to compute it, and it would be whatever well, I'll tell you what it is. So at omega equals 3,000 minus j over omega c equals j 133.33 and j omega L equals j 48. And so that's if you then took so this was 100, this is minus j 133.33, this is 30, this is j 48. So then if you took 100 times minus j 133.33 over 100 plus negative j 133.33 plus 30 plus j 48. If you do all that, you get 94 ohms, which is purely real. If you do this and you get if you do this on your calculator and you get 94 plus 0.000015 j, that j really is not supposed to be there. It's supposed to all be real, and that would be just rounding error. And then the last part, how would this problem have been different did I not put this on? I put it on the handout. Oh, I told you about my computer crashing. This was something I added at the last minute. How would this problem have been different if in part A the frequency was given as 8 kilohertz? So in part A, if the frequency was given as 8 kilohertz, what would we have done differently?
Maybe use the formula.
Omega would be 2 pi times 8 times 10 to the third. And if you don't have this formula memorized, you should put this on your formula sheet too. Omega equals 2 pi f. And I believe he doesn't allow you to have any words, so you can't write angular frequency and frequency. But okay, any questions on this before we move on to the next one?
For C, you just added the omega you found, right? Because I was in. I never know, I'll just look back and look it down.
For C, I found omega,
Oh, wait.
and D, I used that new omega.
No, that's what I meant. Okay,
Yep,
never mind. Okay.
yep. Any other questions?